I'm Anil Kumar. Welcome to my series on calculus. We'll talk about how to find derivative of composite functions. We apply chain rule, of course. We will see how to apply it in this particular video. We have 5 examples to practice. Find derivative of following functions. Okay. So 5 of them are y equals to x squared plus 3x minus 1 to the power of 7, y equals to square root of 2x cubed minus 1, y equals to sine x squared plus x, y equals to e to the power of sine x, and y equals to sine to the power of 5x. Okay. So to break up as a composite function, what you can do is you can define a variable. So inside function in the first case could be x squared plus 3x minus 1. So we could say, well, let u equals to x squared plus 3x minus 1. In the second case, we could define u as equals to 2x cubed minus 1. In the third case, we could define u as x squared plus x. Now we can define u as the exponent sine x. And in the last case, we could define the function sine x as u. So if you do that, then how can you rewrite the function? That is what we'll see now. So if u is defined as this, see how y can be written as. Now we could write y as u to the power of 7. In this case, y could be written as square root of u, right? So it could be written as square root of u. Here we can write y as equals to sine u. In this case, we can write y as e to the power of u. And in this particular case, we could write y as u to the power of 5. Do you get an idea? So if you see this list, these functions are so simple. They are actually composed of 2 functions, right? So splitting a function in this fashion helps us to find the derivative for very complex functions, right? So this is an introduction to give you an idea how to apply the concept of chain rule. And to find the derivative, we know derivative is dy dx normally, since we have the independent variable as x, so we'll always differentiate with respect to the independent variable. U, as you can see, is also a function of x, right? So u is a function of x, y is function of x. So we could find derivative of y with respect to x, and it could be written as dy du, which you're going to get from here, times du dx. Now both these derivatives are very simple and easy to calculate. So we can very easily find the derivative of a composite function. It could be very complex also at times, but breaking them into parts like this, you could even go ahead, right? You could have function of function of function, correct? So that is the whole idea. With this concept, I'd like you to now pause the video, find the derivatives, and then check with my solution. Now I'll take up solution of each one of them one by one. So here's our first one. We need to differentiate y with respect to x. So we'll do the substitution. We have y equals to x squared plus 3x minus 1 to the power of 7. So inside function here is x squared plus 3x minus 1. So we'll write u equals to x squared plus 3x minus 1. Now we could write du dx as equal to 2x plus 3. Correct? On the other hand, once we do the substitution, I could write y as equal to u to the power of 7. Differentiating y with respect to u, what we get here is 7 u to the power of 6. Now, since we know what u is, we could write this as 7 within brackets x squared plus 3x minus 1 to the power of 6. You get it, right? So that is how we do. So these are the steps to be followed. So the first step is define a composite function. And then you apply the chain rule. We need to find what derivative of y is with respect to x. And we know, with respect to x, we know it is dy du times du dx. So we can multiply these two. Dy du is right there. 7 times x squared plus 3x minus 1 to the power of 6 times 2x plus 3. You get an idea. Now as we move along, you should appreciate that if I write y in the function form, let's say as a function of, let's say if we have written y as f of g of x, correct? Now you could see here that y dash is equal to, the derivative of y is equal to the derivative of the outside function times the derivative of inside function. So this is the derivative of inside function. Do you see that? Du dx, basically, which we are talking. And the derivative of outside function is here for you. You get an idea. So that is how we can also see it. Now also, so then we don't really have to show you the substitution, what we did to make a composite function. We could do it direct, right? So I hope you appreciate this point also. So let's move on, practice with the concept you have learned. Now we have y equals to square root of 2x cubed minus 1. Inside function is u, 2x cubed minus 1. If you make that substitution, y is equals to u square root, which we may write as u to the power of half. Now here, differentiating with respect to x, since it is a function of x, can be 6x squared, and here differentiating with respect to u, we get 1 over 2 square root u. Okay? Now what is dy dx for us? So dy dx is dy du chain rule times du dx. Now when you write in this form, it is always a good idea to replace x with the value which it was substituted for. So let me rewrite this as 1 over 2. That is the whole function. Do you see that? So that is the outside function. Correct? So we wrote the derivative of outside function times the derivative of inside function. Do you get an idea? So it is 1 over 2 square root 2x cubed minus 1 times 6x squared. Now it could be simplified and written as 3x squared over square root of 2x cubed minus 1. Perfect? So we just simplified this. This goes 3 times. So I hope the concept is absolutely clear. So let's just extend it to trigonometric functions. Now what we have here is y equals to sine of x squared plus x. The inside function here is substituted by another variable, u in this case. So we have du dx as equal to 2x plus 1. Now once you do that substitution, you could write y as equals to sine u dy du is derivative of sine u, which is cos u. And since you know what u is, you could write this as cos of x squared plus x. And the derivative dy dx is applying the chain rule dy du times du dx, which is derivative of outside function, you see, cos x square plus x times derivative of inside function, which is 2x plus 1. So now I could write dy dx as equal to 2x plus 1 times cos of x square plus x. So I hope that makes sense, right? I would like you to copy this question, do it yourself, and then look into my suggestions. We need to now differentiate y equals to e to the power of sine x. Now substitution which I am going to make is u equals to sine x. So we know du dx is equals to cosine x. On the other hand, once you substitute this, the function becomes y equals to e to the power of u. So derivative with respect to u will be the same thing, e to the power of u. Now since we know that u is sine x, we'll replace this by sine x. Do you see that? Now, multiplying these two, we get a derivative dy dx. So dy dx is for us dy du times du dx, which is equal to e to the power of sine x times cos x. Correct? Remember, you could see this as function of function also. So what you could do here is you could write dy dx also as e to the derivative of the same thing, which is e to the power of sine x times d dx of sine x. And then also you get the same result, correct? So this is a far more efficient way. We may not substitute at later stages, but we could solve it this fashion. So I hope you're getting the concept, right? Now here, the last question is kind of a combination of what we did so far. So I'd like you to do it yourself. So basically here, we could find directly the derivative. So we will do y equals to sine to the power of 5x. So I could get, applying chain rule, dy dx as equal to, first we'll apply the derivative to the outside function, which is 5 sine to the power of 4x times derivative of inside function, which is sine x. You get an idea, right? And so what we get here is 5 sine to the power of 4x times cos x. Perfect. So that is how you could do without substitution. This is also a chain rule, where what we are saying is that if f of g is given to us, right, if this is y, in that case dy dx is equal to f dash, let's say this is f dash of the whole function, right? So let me write gx times derivative of inside function. You get an idea, right? So you can actually apply your rule, what we did for substitution, which is to say that you could do also like this, that let u equals to sine x. In that case, du dx will be cos x, correct? And if that is what you do, then y will be equals to u to the power of 5, dy du will be 5 u to the power of 4, and dy dx is the product of these two, which we got right there. So let me highlight them for you. Just multiply them, replacing u with sine x, correct? So what do you get? You get the result, which is 5. U is sine x, so we get sine x to the power of 4 times cos x. So I hope this concept is absolutely clear. So we have shown it in both nomenclatures, how to find derivative of a composite function using chain rule. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.